Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we will talk about everything that you will need to take this course. Starting off, you will need beginner Python coding skills. If you don't have any coding experience, don't worry. We have included for you a prerequisite section all about coding for Python. That is the next section. So do watch that section if you've never coded in Python before, because you will need to know how to code in Python to build out the machine learning models in this course. If you do know how to code in Python, you can skip the prerequisite section. As well, machine learning experience is not required. We are going to be teaching you machine learning from scratch. You will need a code editor that has Python support. We will be using the free online code editor Google Colab. You just have to go to colab.research.google.com and you can immediately start coding in Python, running Python scripts, saving Python files, all via Google Colab. All you need is a Google account. You can also use a code editor on your computer like Visual Studio Code, but you just have to make sure it has Python extension. So just make sure you install the Python extension. Working with Google Colab, some tips are that variable values can get stuck. Sometimes you run a code cell and nothing seems to happen. So if your variable values seem to not change, just restart the runtime in Colab, but this is a rare occurrence. Usually you'll have no trouble. Some tips for debugging: whenever you come across a problem or a question or an error or something doesn't run as it's expected, just search up your question via a search engine. There are many answers online, especially on Stack Overflow or GitHub. You can even join a Discord server for Python machine learning specialists, where there you can ask questions on Discord. Almost 99.9% of the time, if you have a question, you can find an answer via online. You can also visit the GitHub for the library that you're struggling with. For example, if you're working with the PyPlot library and something isn't as expected, then you can go to the GitHub for that library, because on the GitHub for that library, there's an issues tab where you can read past questions or ask your own question. You can also visit the documentation for whatever you are struggling with. For example, if you're struggling with the Pandas library, go to the Pandas library documentation, which is just their website online. One note before we get started is that this course is not meant to be used as medical advice. The machine learning models that we build should not be used to diagnose yourself or others without a medical professional. And that is what you will need to take this course. As you can see, not much. This course is for absolute beginners. All the source files and data files will be included for you in this course. You can find each of those at the end of every section, so you can follow along with every single step of the way. With every lecture, you can check your code. I'm excited to get started, so join me in our next section.
Hello everyone, and welcome to our machine learning course. Today, you're going to build your first machine learning project. If you have no machine learning experience, that's totally fine. We're going to tell you everything you need to know. All that you will need is some Python experience. First off, we are going to do a bit of theory about machine learning so you know what you're jumping into before we build our beginner project. The first question we have to answer is, what is machine learning? All right, so let's talk about what is a machine learning algorithm. Well, this is an algorithm that can learn from data. So it is a piece of code that can learn from the data it's exposed to. Machine learning seeks to answer several questions, two key questions. Number one, how can we build computer systems that automatically improve with experience? And also, what are the laws that govern all learning processes? These are the two fundamental questions that, ever since machine learning was started as a field, this is what the field is seeking to answer. Let's look at some examples of what machine learning can do. One example is an algorithm can mine through historical medical data to learn which treatment you might best respond to based on your medical data. So you can learn from historical data to make predictions and classifications about the present and also the future. Another example of machine learning in action in the real world today is machine learning can build search engines that automatically customize to your interests. So that's why you see recommendations based on what you've previously searched or even just paused during your scrolling. As well, another example is designing autonomous robots that can learn to navigate from their own experience. So designing machines that can move on their own and improve on their own without any human intervention after the algorithm has already been designed. When should you use machine learning? Well, one case is when the software is too complex to manually design. Because as a programmer, you can only go so far because some software is just too complex. For example, how would you write the software to describe an image? For you to do that with your own algorithm, to learn how to find different commonalities between faces or other images, that software is quite complex. So instead, you write an algorithm to write the software for you. Another time you should use machine learning is when software should change after it is released. For example, you could build a self-driving car, but that self-driving car is only going to be somewhat good when you first design it because the car can then learn from its experience out in the real world after it's been designed. So that is another example of when you should use machine learning, when you want your software to potentially change or adapt or improve after you've already launched it. And with machine learning, your software can actually improve without your intervention. It can improve on its own. Now, there are three branches of machine learning: supervised learning, unsupervised learning, and also reinforcement learning, which is a combination of the two. All right, let's talk about next the workflow of a machine learning project. So here is the workflow from start to finish. First, you will gather your data. And this can be quite a large phase because there's a lot of data out there that you can use that's open source, free to use. But often you'll find data is quite noisy or messy or in the wrong format. And so that's when you move to the next phase of pre-processing your data. So you have to get your data cleaned and ready for machine learning. Then the next step is training your data and feeding it to your model to train your model. And after that, you test the model. And this training the model and testing the model, this is highlighted here because it's part of what's known as a model parameter tuning loop. So this is where your machine learning algorithm learns and improves. You will train it and test it and then repeat, train, test, and you keep improving the training with every iteration of this loop. You train, then you test, you train, then you test. And then finally, once you have built a model that is smart enough or efficient and also effective enough for your liking, then you will deploy the model. So you'll send it out for production and for use. And that is an overview of what is machine learning. We're going to do a bit more theory coming up before we jump into our project. So head on over to the next lecture. Hello everyone, and welcome back to our machine learning course. In the previous lecture, we answered the question, what is machine learning? And in this lecture, we're going to look at the different types of machine learning models that you can build and what their real-world use cases are. Okay, one group of models are known as clustering models. And this type of machine learning model is used to group similar objects. So you could get a whole bunch of data that you collect perhaps from your customers, and you could group the customers into different sequences. So perhaps most likely to buy this next product or unlikely to buy this next product. And clustering models help label data for supervised machine learning. So supervised machine learning relies on labeled input data, which means you must have a label, you must have a tag. For example, every image must have a classification of what is inside the image, like a dog, a cat, a person, etc. And that's just one example of labeled data. And because supervised machine learning, which is a very large branch of machine learning, requires labeled data, clustering models are helpful for providing this labeled data, because there's a lot of data out there that you could possibly collect from whatever project you're working on, whether it's scientific data or data you just get from a free database or data from your store or your customers. A lot of it can be unlabeled, and so with clustering you can group data and therefore label it. Just some examples of clustering algorithms here are k-means, k-means++, k-medoids, and agglomerative clustering, DBSCAN. Now you don't have to worry about these names, I'm just giving you some examples of real-world algorithms that are used for clustering. Now another type of machine learning model is known as regression, and this is actually the project we're going to build together today. With a regression model, the output, so the result of the model, is a continuous value. So one example of regression is for predicting a price of an item based on its features. So predicting the price of a car based on all of its features, like its release date, its brand, its other features that you could possibly think of. Another example is predicting the value of a stock based on its history. That is another example of what a regression model can do. Any kind of output that is a continuous value is an output that could be given by a regression model. Here is a visualization of linear regression. So you have a bunch of data and it may or may not have a pattern, but if it has some kind of continuous value that you could plot on a chart, then you could use regression to find the best fit line between the data points and therefore explain the trend in data. For example, a trend that a stock is increasing in value, or a trend that a car's price will go up if the release date goes up. And some examples of real-world regression algorithms are linear regression, which we'll be building, lasso regression, ridge regression, SVM regression, and decision tree regression. Next up, another type of machine learning is deep learning. And this is where neural networks come in. So the deep learning type of machine learning attempts to mimic the human brain with a neural network structure for algorithms. For example, deep learning is commonly used for classifying images. So a neural network can learn what is inside of an image based on different features in the image. Like it can find the edges of noses and cat eyes and cat ears, and then it could learn what images could possibly contain a cat based on the features it learns. Some applications of deep learning, like I already mentioned, there is computer vision. This is anything that has to do with visuals, or a computer is seeing, if you will. So classifying images, looking at and deciphering what's in a video, all with an algorithm. That is an example of computer vision. Another application of deep learning is natural language processing. So this is anything dealing with understanding speech and text. So you can train a machine learning algorithm to read, or even to write, or to translate, etc. As well, deep learning is used for self-driving cars and making filters for images and creating text. Another type of machine learning model is classification. Classification is going to predict the type of an object within a number of options. So remember, regression will predict some continuous value like a price, which can be on a scale of 0 to $100, for example. But a classification is more binary and categorical. It's going to predict some kind of category, such as, is this image a cat, a dog, a bird, or a plane? It's not a continuous value, it's a category, and that is the purpose of a classification machine learning model. So this time, we're not finding a best fit line of trend of data, but we're separating our data into different classes. Some practical real-world examples of classification that's being used is to check email for spam. You can use machine learning to analyze text and to find common words and therefore classify an email into spam or not spam. And you can also give a confidence score, like I am 60% sure this email is a spam email, is what your machine learning algorithm will tell you. And as well, classification is used to check reviews. So, for example, if a company is releasing a product, it may have a lot of customers talking about the product online. And so instead of manually reading every single review that you get about your product, you can have a machine learning algorithm to check reviews and classify them into positive or negative sentiment based on what people are saying about your product. And this allows you to get feedback from your customers a lot faster. And of course, classification also has applications in science. For example, you could classify the species of a flower or the species of anything, really, with a machine learning algorithm. Just some names of algorithms that are commonly used that are classification machine learning algorithms are k-nearest neighbors, naive Bayes, logistic regression, SVM or support vector machines, decision trees, and an ensemble, which means a combination of any classification algorithms. One example that we saw is k-nearest neighbors. This is a machine learning model of the classification type, and the way it determines if two items should be in the same class is it will assume that similar things are close to each other on a graph when you plot the items on a graph based on their features. So this type of algorithm will calculate the distance between points on a graph to identify similar objects. So it will first have to plot every item, every data sample onto a graph based on different feature values, and then it can find if two objects are similar, then that means they are close to each other on that graph. So that's just one example. All right, and naive Bayes is another example, and this type of classification algorithm assumes that the presence of a feature in a class is unrelated to other features. So this is similar to k-nearest neighbors because they're all similar because they're part of the classification group, right? But with naive Bayes and all the other ones, they just have slight differences that distinguish them from each other. So with naive Bayes, each feature of a data sample is considered independent of all the other features. For example, if you have a cat image, it could have features about whiskers, a tail, and a nose. But with the naive Bayes algorithm, instead of taking into consideration the combination of features, it treats each feature as an independent feature. That's just a slight difference that will distinguish this type of classification algorithm from another. Now here's another example of classification, this time a scientific example where we have three types of flowers: Iris virginica, Iris versicolor, and Iris setosa. This is a common example and a common project that you'll see built for beginners. And here we use two features of the flowers, petal width versus petal length. And then we plot each flower sample on a graph using their petal width versus their petal length. And then if two flowers are close to each other on that graph, then it's considered that those two flowers are likely the same species. So this is just one practical example of a classification algorithm. Another type of classification algorithm is logistic regression. And this is used when the dependent variable is categorical. So it is similar to linear regression, but instead of having an output that's continuous, the output is a class or a category. And for example, it can classify, is a review positive or negative, or is an email spam or not spam. So it will take in different features, for example, features x1, x2, x3, and it will feed them to an algorithm and produce a result. Another type of classification algorithm is support vector machine, and this will find a plane that has the maximum distance between data points of both classes. So it's another type of classification algorithm, but the way it does the classification is different. So here we have all of our data points, all of our data samples being plotted on a graph of some features versus some other features. And then we find the maximum distance between the points to be able to categorize them into two distinct classes. And those are just some examples of types of machine learning models. There are a lot of machine learning models out there, and you can learn them as you go. So as you start a project, you can learn a new model, because there are quite a lot, but for a beginner, you can start anywhere. Next up, we're going to do a bit more theory, and then we will jump into our project. So head on over to the next lecture. Hello, everyone, and welcome back to our machine learning course. In this lecture, we're going to answer the question, what is supervised learning? Because the project that we'll build today is going to be a supervised learning machine learning algorithm. All right, so let's talk about supervised learning. This is a type of machine learning branch, and it is a large branch of machine learning. With supervised learning, a model learns a function that maps an input to an output. So an algorithm will learn how to describe the relationship between an x and a y. X is your input, and every x has an output pair known as a y. And let's talk about how the algorithm works. First, the algorithm will analyze your training data, and it will infer a function. It will learn the relationship between x and y. And then you can use that function that the machine learning model found to determine classes of brand new data, which means you can learn the model to then later on use it to find a y for an unknown x. For example, if your machine learning model learns the relationship between your employee and the number of sales they had that month over a whole year, then you can use that data and the trend and the relationship that the machine learning model found between the month versus the employee and their sales, and it can predict what will be the sales of that employee next year in March. That's just one example of what supervised learning can do. There is a parallel task in psychology for supervised learning, and that's known as concept learning. So a concept is a category of stimuli that have features in common. So concepts have to have features in common. For example, here we have 3 triangles, and we can see that these 3 different objects, these 3 different samples, they have stuff in common. They have features in common. They both have 3 sides, which is why they're triangles, and the sides are 3 straight lines as well. And as well, all the triangles are shades of red. So that puts all 3 of these samples into a common category. With concept learning, it gives the ability to apply knowledge across a variety of circumstances. So not only do you learn from the 3 pieces of samples we just had, those 3 triangles, but you also can apply this knowledge to new triangle shapes that you've never seen before. And this is what you do as a human when you learn different categories of objects, and it's what a machine learning algorithm learns to do as well. It learns how to recognize a triangle based on features of a triangle, and then with this knowledge, it can then recognize triangles in the real world. That's just one example of what machine learning can do. Now, concept learning is from psychology in Gagne's hierarchy of learning, starting at signal learning, then stimulus response learning, chaining, verbal association, discrimination learning, concept learning, principle learning, and problem solving. This is how humans begin learning, from signal learning all the way up to problem solving. And machine learning has the equivalent to concept learning of supervised learning. Now, of course, you are taking the human brain of psychology and applying it to computers, so there will be differences, but it's a good analogy. The first step to building a supervised learning algorithm is to determine what kind of data you have. What is the type of your training samples? Do you have triangles? Do you have images? Do you have sales numbers? What do you have? Do you have a handwritten character, a handwritten word, a handwritten sentence? You have to get specific. Then the next step is to gather your training set. So you have to get data, you have to get sales numbers or stock values, you have to get the inputs and also their output pairs. Your training set should be representative of a real world use of the algorithm. So you have to get realistic data. Then after that, you have to represent your input features, because this will affect algorithm accuracy. Now, this gets into more complex projects. For example, working with images, you have to compress your images, otherwise images have way too much data. But you also do have to clean your data, so you have to get the most important features, because some features could be irrelevant. For example, if I'm trying to predict the value of a stock that tomorrow, based on the history of that stock's prices in the past, well, there are a lot of features about a stock that I could use. I could use the stock's opening price, the closing price. I could use external economic data. But there are other features that are completely irrelevant, like, for example, the weather that day in New York. Well, that feature could be relevant, but it could also be irrelevant, but it's just in my data set because that's the data set I found. So you have to clean your data set to get the most important features, because otherwise some features can actually hinder your algorithm if they're not useful. Now, if you're working with images, you have to transform your input into a feature vector. And this contains features descriptive of the input. Now, if you don't have an image, you have some other data, well, you still have a feature vector. You have an array of features. For example, if you have a data set full of triangles and squares, and you want your machine learning model to learn how to recognize triangles and squares, well, each sample will have an array or a list of features. For example, the number of sides, the number of straight lines, the perhaps width and height, area, perimeter, and those could be irrelevant features, but the relevant features will be the number of sides, because a triangle has 3 sides and a square has 4 sides. So every sample will have a list of features. Now, a sample can actually have just one feature only as well. That's valid as well. But if you're working with more complex projects, then each of your samples will likely have a lot of features about them. And note that the number of features should not be too large, because that is going to make your algorithm quite slow. And if you have a lot of features, it's quite possible that those could be too many, because really, if you have too many features, it means you could have a lot of noise in your data and the features are irrelevant. So you have to contain enough information to accurately make a prediction, make a result, but don't go overboard with having a lot of features just because you think more features will help. That's not actually the case. And then step 4 is to determine the structure of your machine learning algorithm and the function you want to create. So do you want to create a linear regression model or a logistic regression model? Do you want to do classification or regression? What model do you want to use for this specific problem? Each machine learning project you create will require likely a different algorithm. It all depends on the project. Oftentimes you can use the same algorithm type for different projects, but sometimes you may have to try other types of algorithms to see if you get a better result. So you have to decide, do you want a decision tree? Do you want a neural network? What type do you want? Then once you've decided that, for example, in our project, we'll decide that we're going to use linear regression, which is a type of regression model. Then you can train your algorithm, so your regression model, with your training data set. So you will put your algorithm to learn your data set. As the model learns, it will adjust parameters in that training and testing loop. So after you train, you will also evaluate the accuracy of the model to see if it trained well. And if the training did not go well, you can train again and keep training until your accuracy improves. Or you can change the algorithm type if you don't get good results. You could change the regression type you're using. You could also adjust your algorithm as well. So more into that later on when you build more complex machine learning projects. All right, once you have trained your algorithm and evaluated your accuracy, then you can deploy the model for use once you have an accuracy that you are happy with. And that is supervised learning. Supervised learning is a big branch of machine learning, and you need to know what it is because we're going to build a project that is a supervised learning project. Coming up, we are going to introduce our project type. So head on over to the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy it before the sale ends. Thanks for watching, and I'll see you in another video.